Okay, so task 7 is balancing the equations. Now this one's probably, for some people it's a bit daunting, other people think it's easier than what's been done previously. So you are given the formulas already, so you don't have to work out those, they are already balanced. What you are doing is just balancing the number of atoms on the reactant side with the number of atoms on the product side. So if we look at the first one, we've got nitrogen mixing with hydrogen to make ammonium. We have 2 nitrogen, 2 hydrogen, 1 nitrogen, 3 hydrogen. Choosing to balance this one, I would start with the nitrogen and say, well, there's 2 here, so let's make it 2 here. So we put a 2 in front, changes that to a 2, changes that to a 6, remembering that this number multiplies the little number out there. So it's essentially saying we've got two molecules of 1 nitrogen and 3 hydrogen. So we've got to count how many, so it multiplies everything that's involved in it. Of course, remembering that you can draw them if you want, if that's easier for you to count. It just saves time to start doing it without drawing it. Okay, we look at the next one. We've got 1 potassium, because there's no little number before or after it. There is 1 chlorine, and there are 3 oxygens. We go to the other side, and we've got 1 potassium, 1 chlorine, or chloride I should say, and 2 oxygens. We're going to balance these ones. Now remembering that you can only add, you can't subtract molecules, you can't just add another oxygen. So I'm going to look at this and I say, right, well, what's the common multiple between 2 and 3? It's 6. So I need to change this to 6 here. So I do that by putting a 2 in front. What that does is it changes that to 2, that to 2, and that to 6. Change this one over here. I need to put in a 3 to make that 6. And then to balance the potassium and chloride, I need to put a 2 here. Sodium, I have 1. Chloride, I have 1. Fluorine, I should say, I have 2. I have 1, 1, and 2. So I need to balance this. I'm going to start by balancing the fluoride, or the fluorine. So there's fluorine on this side because it's an elemental molecule. It's fluoride over here because it's bonded ionically. To do that, I'm going to put a 2 in front of that, which changes the sodium to 2 and the fluoride to 2. Which now I need to change the sodium over here, so I'm going to put a 2 in front of this, which changes that to 2 and that to 2, and we are now balanced. Hydrogen, I have 2 hydrogens, 2 oxygens. I have 2 hydrogens, 1 oxygen. I'm going to balance the oxygens first. Oh, sorry, 3 I should say, because there's 1 here. There's 1 here and there's 2 there. So I'm going to double that, which doubles my hydrogen and my oxygen, which means I need to double the hydrogen over here, which gives us 4 there, and it's balanced. Silver, there's 1 silver because there's no number in front or no little number there, so it's 1. Now, nitrate, because it exists as exactly the same molecule on the other side, so NO3, NO3, we count it as a molecule, we don't count it as the individual elements. You can, and it will balance, it's just an extra step in terms of balancing that makes it harder. So there's 1 nitrate, there's 1 magnesium, and there are 2 chlorides. Over here we've got 1 silver, 2 nitrates, 1 magnesium, and 1 chloride. So I'm going to balance my chlorides first, and I'm going to do that by putting a 2 in front of this, which changes that to 2 and that to 2. That now means I need to go to the other side and say, well, silver now needs to be 2, so I put a 2 in front of that, which changes that to 2 and the nitrate to 2, and I am balanced. I choose to use a different colour so I can track where I'm changing. If I had to change it repeatedly, then I'd use a different colour each time. Aluminium, there's 1. Bromide, there are 3. Potassium, there are 2. Sulfate, there is 1. Sulfate 3. Aluminium 2, bromide 1, potassium 1. I'm going to leave potassium and bromide to last and change the other ones first, just because I know that they're going to be trickier to do. So I'm going to say I need to have 3 sulfates, so I'm going to put a 3 in front of this one here, which makes that 3 sulfates, and then 6 potassium. I then go to the other side and go, right, well I want 6 here to change that one, but it also changes the bromide. What I can do is put a 2 in front of the aluminium bromide, which makes that 2, makes that 6, and I'm balanced. Iron chloride, there is 1 iron, 3 chlorides, 1 sodium and 1 hydroxide, and again, because the hydroxide is the same on both sides, we count it as a single unit. 1 iron, 3 hydroxides, 1 sodium, 1 chloride. I'm going to balance my chlorides first, so I'm going to put a 3 in front of here, which changes that to 3 and that to 3. I'm going to put a 3 in front of this one, which changes the sodium to 3 and that to 3. 1 carbon, 2 and 3, 6, 12, 6, 2, 8. I'm going to balance my carbons first, leave oxygen to last because oxygen's by itself. So to balance my carbons, I'm going to put a 6 in front of that, which changes that to 6, and it changes this to 6 times 2 is 12, plus 1 is 13. I'm going to balance my hydrogens next. I'm going to say 6 water, so I've got 6 hydrogen, plus 6 oxygen on top of the 12, we've got 18. Over here I've only got 8 at the moment. I need to have 18, so I must need 5. 6 is already there. I've already got 6, so 18 take away 6 is 12, which means I need 12 more, so I now have 18. 1 hydrogen, 1 chloride, 1 calcium, 1 carbon and 3 oxygens. Now the reason we've had to break the carbonate apart is because over here it makes carbon dioxide and water. We go 3 oxygens, 1 carbon.
Mr. Wilson, can you please contact the General Office? Mr. Wilson.
2 hydrogens, 2 chlorides and 1 calcium. So the only thing that needs balancing here is the hydrogen and the chloride, so we go over here and add 2. And we're done. Last one is a combustion reaction, fuel in oxygen. I've got 6 carbons, 14 hydrogens and 2 oxygens. I have 1 carbon, 2 hydrogens and 3 oxygens. Start with your carbon. So I'm going to put a 6 in front of that, which changes that to 6. 12 plus 1 is 13. I'm going to balance my hydrogens next, so to get 14 I have to do 7, so that is 7 is 14, 7 oxygens plus 12 is 19. Now the problem we have is that we must have an even number, so we're going to have to double this side first. Okay, so then we go over here and we do the same. So in order to do that we have to have 12, we need to have 14. That gives us 12 times 2 is 24 plus 14 is 12 is 26, which means we need to have 13 oxygens over there.